So now we're going to look at Chapter 5, Section 5 on solving multi-step equations and inequalities. So our first example, we're just going to review a little bit first to make sure that you remember how to solve with distributive property and to make sure you remember rules for inequalities. So I'm kind of combining Chapter 4 and what I just taught you in Section 4 of Chapter 5. So distributive property, remember you have to distribute that 4 to both things inside those parentheses. So 4 times x is 4x. Bring down your minus. 4 times 3 is 12. Bring down the symbol, greater than, and bring down the 6 because we haven't done anything with it. Now I want you to draw your fence so that you remember whatever you do on this side, you have to do here, okay? Now this looks like a two-step equation. The only difference is it's an inequality instead of an equal sign. So if it were an equation, you solve this the same way. You're going to add 12 to both sides because if I do it on the left, I also have to do it on the right to keep it equal and balanced. This is 0. Bring down the 4x. 4x is greater than, you just bring down the same symbol you already used. 6 plus 12 is 18. Now you're going to undo multiplication by division. So I'm going to divide both sides by 4. So x is greater than 18/4. Or if you went ahead and did that division out and wanted to change it as a decimal or a mixed number, you would get 4.5. That's really, sorry. 4.5 or 4.5. Any of those answers are acceptable. Okay, so for our second example in this section, we're still going to use distributive property to solve this, but this time it's distributive property twice because I have to get rid of these parentheses before I can do anything. So I'm going to start on the left because we always start on the left and work our way to the right, just like in reading. I'm going to draw my fence. 4 times x is 4x. 4, bring down the plus sign. 4 times 5 is 20. The equal sign stays in the middle. Apologize for my marker. Now I have to do the same thing over here. Distribute your 3. 3 times 2x is 6x because 3 times 2 is 6. Bring down the plus sign. 3 times 4 is 12. Okay, so now this looks like something that you've seen in Chapter 4, where you have a variable on both sides and you have a number on both sides. So you need to choose which side you want your variable and which side you want your constant. I am going to put my variable on the right and my constant on the left. So I'm going to subtract 4x on both sides first. This is gone. I bring down my 20. 6x minus 4x is 2x. Just a minute, Keenan. Plus 12. And then I'm going to subtract 12 on both sides because I want the constants together on the same side. This is now 0. I'm left with a 2x here. 20 minus 12 is 8. I have multiplication here in between these two because they're side by side. To undo multiplication, we divide by 2 on both sides. So I have 4 is equal to x. So a lot more steps than what we're used to. In this one you have 1, 2, 3, 4, 5 steps. Again, let me know if you have questions, post them to Edmodo. I'll be more than happy to help you. Okay, so example 3, I'm actually going to take out of your book. So I'm going to go over here to page 249. That's where we're looking so that you can see the story problem. It says, Mariella's parents have budgeted $575 for her quinceañera. The cost of the party room is $75. How much can the family spend per guest on food if each of the 40 guests receives a $5 favor? All right, so the first thing we need to do is break down our words, and I want you to use cube on this to help you. So remember, cube, you're going to circle numbers, underline what it wants you to do, box keywords, and then evaluate. Okay, so they budgeted a total of $575. So $575 is my total amount, okay? So that's my party cost, or my total. I know the cost of the room is $75. And I know that they're spending $5. There's 40 guests, and the cost per guest is what I'm looking for. They're receiving $5 favors, okay? So the cost per guest is whatever letter I pick. I'm going to do G plus my $5, okay? Because it's however many guests plus 5. But then I also need to keep in mind that there's 40 guests. Okay, so I'm going to go over here to the whiteboard so you can see what I wrote down. So my total cost was $575. That's the total, so it's with the behind in front of the equal sign. My room is $75. The cost of each guest is food, which I don't know, or guest cost, plus the $5 favor, times 40 guests. So this is what my equation looks like. I then need to solve it using the distributive property, and then my steps to solve a typical equation. Okay, so 575 is just going to stay here. 75 stays there. Distribute or multiply the 40 by both things, so plus 40G. 40 times 5 is 80. No, it's not. Sorry. I'm on 200. Sorry. It's 200. 4 times 5 is 20. I read that as a 2. Sorry. My apologies. All right. Then I need to combine like terms. So I have 575 here. 75 plus 200 gives me 275 plus 40G. Okay, now I'm going to leave the variable on my right, so I need to move the 275 to the left. It's a positive number, so I'm going to subtract it from both sides. This marker is starting to die on me. I apologize. So I'm left with 40 guests here, 40G. 575 minus 275 is 300. These two things are multiplied together. To undo multiplication, we divide. Zeros are going to cross. 30 divided by 4 is 7.5. Now these are dollar amounts, so $7.50 per guest on food is what they can spend. Okay, I'm going to switch markers. Let's look at how to do something like this. You do it the same way we did with the one with the equal sign, except you have to remember that run rule. If you end up multiplying or dividing by a negative, you have to switch the inequality to go the opposite direction. Sorry, my power just went out. Lights flickered. So let's look at how to do this one. 5a minus 8, and the symbol stays the same. Distribute first. 4a, bring down the minus. 4 times 3 is 12. Okay, now it looks like something we've seen before. I'm going to add 12 to both sides. 5a plus 4, because it's negative 8 plus 12. It's greater than or equal to 4a. Now I have to bring this 5a over here. To do that, I'm going to subtract, so minus 5a on both sides. The 4 stays. I haven't multiplied or divided by a negative, so this all stays the same so far. 4 minus 5 is a negative 1a. Now, I have a negative here, so I can't leave that as my final answer. I actually have to divide by negative on both sides. So I get a negative 4 is less than or equal to A as my final answer. So again, we divided by negative, so I have to switch my inequality symbol. All right, let's talk about null set or empty set and identity. So before I do the examples here, the null set or the empty set means it has no solution. Okay, if we're representing the null set with a symbol, it would look like a 0 with a line through it. Okay, an identity means that it's an equation that's true for every single value of the variable. Okay, identity is true for every value of the variable.
I'll show you what I'm going to do with your train.
Okay,
Watch.
so let's look at example 5 here.
Look what I do with my Hannah. Pick your arms up.
Let's say I have 3 times y minus 5
Hannah, you gotta have this thing
plus
turned on.
25 equals 3y plus 10. So we're going to distribute this 3 first. So I get 3y, bring the minus down. 3 times 5 is 15 plus 25. 3y plus 10. Sorry, my children are having fun with trains right now. Simplify 3y, combine negative 15 and a positive 25 to get plus 10. Now, you actually can stop at this point, but we'll keep going so you can see what's going to happen. But notice that 3y plus 10 on this side and 3y plus 10 on this side. Both sides are the same. So if I solve and take away 3y on both sides, I'm going to get 10 is equal to 10. Well, 10 is always equal to 10, which means this is an identity. Okay, so I have a constant is equal to a constant. It's the identity. Now let's look at, same thing, but let's look at what would happen if it was a null set. What will it look like when you solve the equation? So I'm going to call this example 6. Let's say I have negative 5x minus 14 equals 2 times 2x plus 3 minus 9x. All right, looks like a mess up here. We're going to get it so it's easier to work with. So I have negative 5x minus 14 on this side. That's staying the same for now. I'm going to distribute this 2 because I have parentheses. I need to get rid of them. 2 times 2x is 4x. Bring down the plus. 2 times 3 is 6. And bring down the minus 9x because I haven't used it yet. Combine like terms on this side. Here I have negative 5x minus 14. Hannah, honey, you're okay. 4x minus 9x is a negative 5x. Plus 6 stays the same. Hannah, it's okay. All right, now we're going to add 5x to both sides. So I have negative 14 is equal to 6 because that's 0 and this is 0. Well, negative 14 does not ever equal 6. This could never be true. So we call this the null set. Or we can put a symbol by that representing that it's never going to be true.